it matters from a networking perspective. This Kali box, Kali is a offensive security operating system. So like there's Windows, there's Mac OS, Windows 7, Windows 8, Windows 10. Kali is a Unix distribution that's rolled or built custom for security practitioners. You can Google Kali, there's tons of information, there's tons of resources, but it's a pretty standard offensive security toolkit. You can see that it is on a network right here, and we have Security Onion and OpenSUSE. Don't worry about these so much, just think of them as like other endpoints on the network. pfSense is a firewall, and OWASP BWA is a web server that's intentionally vulnerable. So really what you need to know is this is a Kali box, which is where we're going to be operating from. These are some devices on the network. This is a firewall, and this is our target right here, this OWASP BWA. Now you can see the IP address here. This is IPv4 address schema, and 192.168.9.0/24. So that is CIDR notation, CIDR notation. You don't really need to understand that for the purposes of this lab and really for the purposes of this course, since it's an introductory level course. But just know that /24 indicates that it's 192.168.9.0 through 192.168.9.255, right? So that fourth octet can be between 0 and 255. So any devices on the network can have one of those IP addresses. And you can see here this local area network is 192.168.0.0/24, which again means 192.168.0.0 through 192.168.0.255. When you write it down, it makes a lot of sense. You can see, so there's the 255 possible IP addresses, and you can see the SUSE has the .30 and the Security Onion has .100. So if I was to plug in a laptop on that local area network, it would get an IP address of something of 192.168.0. something, but not .30 and not .100 and not .2 because the Kali box has that. Okay, hopefully that's clear. Now, if you look in the lab manual, you can actually see, it's kind of cool, they actually kind of give you the IP addresses. So remember, IP addresses are unique on a network, right? And the 192.168 is a non-public routable IP address. I will mention this in the lecture. It allows us to basically not run out of IP addresses. We're going to be working from that Kali box. So let's figure out how we're going to get in there. Click on the Kali tab, okay? So this is our Kali tab right here. And this is what the front end of Kali looks like, right? This Linux box. We're going to log in with root, R-O-O-T, and Tor, which is root backwards, okay? Great. So it pops up automatically with the console. So this is a terminal shell. This is where a lot of tech people, frankly, cybersecurity practitioners will operate from, is the terminal shell. And it's not magic. It's not anything crazy. Let me zoom in a little bit if I can. Can I zoom in? No, I don't want to do that. I don't know. Let me know if you can't, if this is difficult to see, and I'll figure out a way to expand it. But the very first thing we're going to want to do is disable Docker. Now, this has nothing really to do with the lab. It has to do more with the fact of the way that this lab environment is built. So we have to do this systemctl stop Docker, which basically stops the Docker service, which is something that's unrelated to the lab. But if we don't stop it, it's going to interfere with what we're trying to do here. So as I mentioned, we're going to be using this tool called NMap. NMap. Now, for any Linux tool, if you type in man, which means manual, like the manual, the user's manual, man, and then the name of the tool, in this case NMap, you'll be presented with like a help page. So if you're ever using any tool, it doesn't matter what, like in a Linux environment, and you don't know how it works or what its purpose is or anything like that, you can do man and then the application, and you should get some type of information. You can press the space bar to kind of run through it, You can see all of this different functionality that NMap has. We're barely going to scratch the surface with this tool. When you're done looking, you can press Q to jump back to the terminal shell. All right, so we're going to do NMap 192.168.68.12, which is our web application, our vulnerable web app that we're wanting to scan. So we're the Kali box, and we're going to be scanning through a firewall of that web app. Very quick results, right? So you can see these are all TCP ports. This number right here indicates the listening port on the web application server. Now remember from the networking lecture, there are IP address at the network layer, and then above that is the transport layer, which can have multiple listening services all at once, right? So you could have a server with one IP address that has a mail server and a file server and a web server all running on it, right? Just like this. So this is one machine with multiple listening services. Now, I do want to point out that the total population of ports is around 65,000 and some change, right? So you can't have port 75,000. There's a finite limit. Just like on the IPv4 schema, you can't have an octet that goes above 255, right? It's 0 to 255, always on those IPv4 octets. Same thing kind of with these ports where it's 1 to 65,536, I believe. But you can't go north of that. So let's do another scan consistent with the lab here. NMap-ST 192.168.68.12. And this is with the TCP flag enabled, right? So remember, it's TCP and UDP at the transport layer. If you look quick, you can see that basically the ports it finds are identical. So we didn't really gain anything there, but it's just confirming that we're running the TCP one only. Now, as I mentioned, we would be running all 65,000 here. So if we want to be less noisy, because defenders who are managing this system or the security of this environment might notice an NMap scan scanning 65,000 different ports, right? Like basically this server got interrogated on all these ports sequentially, which is a dead giveaway that it's being scanned. So if we want to lay a little bit lower and be a little more quiet on the wire, you can do this -F command or flag, excuse me, and it'll do just the most popular ports, okay? Which kind of blends into the noise because those ports are likely up anyways. So I've just run the scan again, and what you'll notice is this port 5001 that it found with the regular scan is not here because it's not the most popular, right? Oh, and I also want to point out this NMap scan worked really quickly, but it only did 1,000 ports, right? So you could see here when it did the most popular one, it scanned, I guess there's probably 8 here, so it scanned 100, right? So with a regular NMap scan, it does 1,000. With the -F, it just does the top 100 listening ports. If you really wanted to, you could, this isn't part of the lab, but you can do like TAC-P means which port. I mean, you could say 1 to 65,000, right? And do this. There's probably nothing listening up in that upper range, but but you can do it. And you'll see, like, you see how it's going to take a while. And this is part of the reason why you wouldn't scan up in that range unless you wanted to, because I don't want to wait for it. Okay, so I hit Control-C to break out of that command. Now, following the lab, I'm going to use the TAC-A command, which is what I normally use, 192.168.68.12. Now, what the TAC-A is going to do is it's going to try to identify the versions of the software that's running. So you can see that it found, for example, this SSH secure shell. This is like a way to like remote into the box. It also found a web server, right? We're all familiar with HTTP when you go to the websites and stuff like that. That's what this is, a web server. But what kind of web server is it? Is it Apache? Is it, Nginx? Is it Tomcat? Like, what web server is it? So this TAC-A argument is going to help us with that. It's going to give us some information. It will take a minute to execute, so I'm going to jump the video. Okay, so that did take a few minutes, but you should get similar results to this. And what you can see is, again, it's going to have all the same ports, right? Here's that secure shell, but it's telling us more. OpenSSH version 5.3p1. It's a Debian, version, right? So it's probably, the web server is probably a Debian Linux box underneath. Here's that web server, right? Port 80. It's running Apache version 2.4.3 with PHP 5.3.2. Now, you can see the rest here for yourself, but what is this, why do I care about this, Jerry? I don't get it. Here's why. The next step, once you understand what version it's running, is this. Watch this, right? Exploit and then copy paste. Here we go. Anything less than OpenSSH version 7.7. Here is literally a copy and paste exploit. You can just punch a hole right in the side of this server and take it over, right? So that's the power of understanding what version of that software is running. We're not going to do it for this lab, but you get the idea. This is what makes the tool useful and interesting. It's NMap is a network reconnaissance tool, and it gives you a lot of information, and this is why it is wildly popular with cybersecurity professionals and why it's been around forever and it continues to be used as a primary tool set, is because of this. Now, what I really wanted you to get out of this lab is understanding that this is what IPs look like and how we're scanning and looking at listening ports and stuff like that, all the kind of tie in to the networking lecture. Okay, so don't worry about the final step 13, the SC one. That's not really relevant to the lab. Just to submit something so I know that you did the lab, just take a screenshot of this page of you having run the -A argument, right? Simple like that. And just upload it as your lab thing. There's nothing to write up here, just a screenshot. What I wanted you to do is walk through and kind of get a little bit of experience, A, with NMap, B, with network layer stuff and transport layer stuff, and also using a terminal shell and getting some exposure to Kali, okay? So submit those uploads, hit the deadlines, right? I think this one's due July 4th, so definitely don't want you to miss that. And I hope you enjoyed the lab.